We're doing chi-squared test using Microsoft Excel. Again, this is a worksheet from Cougar Courses under the chi-squared lecture. So first we're going to do the one-factor chi-squared test and then a two-factor chi-squared test. First we'll kind of do each one, the step-by-step, kind of the long way, so we can kind of learn the theory behind the chi-squared test. Then we'll do the chi-squared test, very fast. So you can find out how to do this very quickly if you need it for this class or for another class. Okay, so over here we have the expected, the administration, they wanted this % of each letter grade. This is, the one teacher, how many he or she gave out, from their 141 students. So based on 141 students, go 141 times the 10%, we get 14. So it looks like I've calculated this for us, but basically I typed in 141. Well, here, let's do it. I did equals, and I typed in 141 multiplied by the 10%, and I clicked on the 10% and hit enter. And that way I can just drag it down for all of them. So observed minus expected is just that. So I'm hit equals, click on the observed, minus, click on the expected. Notice it's going to total up the observed minus expected here in green. Again, we want to do that for all grade levels. Oops. So we just copy it down for all grade levels. Again, observed minus expected is always going to be 0. If you give out too many A's, well, there's going to be, there'll be less than expected of some other grade level. Then we want to square each one. So that's equals, and I'm going to click on the 16 for the difference between observed minus expected, and then caret 2, which means raise to the second power or squared, and hit enter. Oh, got the pinwheel. Okay, and copy it down for all. Here we probably have more decimals than we need, so I'm just going to get rid of some decimals. Now we just go observed minus expected squared divided by expected. So observed minus expected squared divided by, click on the expected number, and then copy it down for all. So sorry, I should have mentioned in the beginning, this is what we're doing. We're trying to calculate the chi-squared value, and it's calculated as the sum for all levels of the observed minus the expected squared divided by the expected. So here we have the observed minus expected squared over expected for the A's, B's, C's, D's, and F's. So the chi-squared value would just be the sum of all these observed minus expected squared divided by expected. So we get a chi-squared value of 35.3. So the degrees of freedom is the number of levels minus 1. So we have 5 levels. Grade is like our factor. There's 5 levels, A, B, C, D, and F. So 5 minus 1 is 4. So I'm going to type in just that. Then we want to find the p-value. Did the teacher give out, differ from the grading policy based on, what they gave out? So if the p-value is less than 0.05, we'll say yes, the teacher did differ from the grading policy. If the p-value is greater than 0.05, then we'll say no, the teacher did not differ from the grading policy. Or in other words, the teacher's grades match the grading policy. We're not different. Okay, so it's chi distribution. We'll tell it a chi-squared value in degrees of freedom, and it'll return a p-value for us. So chi-squared is x is the first is asking us for x, which is a chi-squared value. So I click on that, comma, degrees of freedom. I'm clicking on the degrees of freedom, parentheses, and hit enter. So we get a very small p-value. So yes, the teacher did differ significantly from the administration's grading policy. So again, that was a lot of work. If we just already had the observed and the expected columns calculated, well then we could have the computer do all the math for us. So that's chi-test for chi-squared tests. So CHITEST parentheses. So actual is our observed. So I highlight the observed, comma, expected is what we expect. So parentheses and hit enter, and we get the same p-value. Okay, so that was the education administration. Yes, the teacher did differ significantly from the grading policy, at an alpha of 0.05, because the p-value was less than 0.05. So now I'm scrolling down here. We'll do this swimming example. So this is a two-factor example. The two factors are teaching method, or coaching method, I should say, and then how about skill level? So the teacher wants to see if one method, people were classified as, better or worse than the other method. So basically here, and I guess I've done this part for us, we need to add up each row and add up each column. So I'll just show what I did. I did equals sum of good, average, and poor for the new method, and now we got the 55 people who were taught the new method, 52 people were taught the traditional method. Likewise, 36 people were scored as good swimmers, 46 were average, and 25 were poor. So now we need to calculate the expected. And sorry, I don't have the formula here, but it's this, for each, for new good, we're going to look at the sum of the new column, multiply it by the sum of the good column. Sorry, let me say that again. The sum of the good row. Wait, I'm trying out a third time. Sorry, one more time. Okay. The sum of the new row times the sum of the good column divided by the total n will tell us how many we'd expect to see. So let's try that. Equals, so new good, sum of the new row times sum of the good column divided by n. Okay, we'll do that for each row. We're just going to go one by one. So we'll say, okay, traditional. So we'll go, how about sum of the traditional row times, these were scored good, so sum of the good column divided by our total. Okay, average, so that'd be equals 55 times 46 divided by 107. Oh, I can just click on 107. Okay, now we're on the bottom row, so that'd be equals 52 times 46 divided by 107. Poor, we got the new method, so that'd be equals 55 times 25 divided by 107. And then for traditional, 52 times 25 over 107. So now we got our expected, and these numbers have been put in right here. So actually these, I'll unround them a little bit so we can see they're the same numbers. So now we just go observed minus expected, same as we did before. So maybe pause the video here, work out, get your chi-squared value, and then play it back and see if you did it correctly. Okay, so I'm doing observed minus expected. So equals observed minus expected. Hit enter. Okay, do that for all. Notice the sum is 0. It's always going to be 0 for observed minus expected. Okay, now we square the observed minus expected. Do that for all of them, and then divide observed minus expected squared by the expected. Do that for all of them, then add them all up. Okay, degrees of freedom. Here's our formula. So here it's k minus 1, k1 minus 1 times k2 minus 1. So the number of levels in the first factor minus 1 times the number of levels in the second factor minus 1. So it's 2 minus 1 times 3 minus 1, which is 1 times 2. So that's 2. Okay, I want you to just watch this part. If we say, okay, oh, sorry, that's later. Let's work together. So we're going to do the chi distribution. Sorry, oops. And it's x, comma, degrees of freedom. And we get a p-value that's greater than 0.05. So, know how the students were rated was not dependent on which teaching method they got. So there was no difference between teaching methods because the p-value is greater than 0.05. Okay, here's the tricky part. So if I were to go chi test and go observed, comma, expected, the computer is going to think, okay, this is one factor with 6 levels. So if I hit enter, we get a different p-value. So you can still use the Excel to do this. We just need to tell the computer that it's 2 by 3, meaning the first factor has 2, the second factor has 3. So for actual range, I'm going to go up here to the observed and put in the same numbers, just oriented in a 2 by 3 box. Then hit comma, then do the expected, again in the oriented in a 2 by 3 box. Now when I hit enter, I'll get the same p-value. So it knows that it's not one factor 6 levels, but 2 factors, 2 levels for the first factor, 3 levels for the second factor. So that's the chi-square test in Excel. What you're going to do next is copy these data, just the numbers, 1s, 2s, 3s. Copy these data into SPSS, and then you'll be ready for the next video where we'll do the chi-square test using SPSS. Okay, until next time.